I believe if the people who created the TCP/IP model did this differently, we would never have heard of the OSI model to this day. This is it, the travesty. TCP/IP grouped the bottom two layers into a single network access layer. And I can totally see why they would do that. They're creating a protocol. It works up here at the higher layers. The people who created TCP/IP were probably like, and then once it's done with our stuff, it just kind of it does its thing. We don't deal with that. So we're just going to kind of group that together into one big blob. Whereas the people who created OSI were like, no. There's two things. Even though we may not deal with this with the OSI protocol, there's two separate functions down here, the data link layer and the physical layer. See, here's the concept. There are different physical ways of communicating across the network. Think about it. We have our computers nowadays. You could plug them into a fiber optic cable, and it's now using light signals to transmit its ones and zeros across the network. We could plug it into a copper cable, which most people do, and it's now using electrical signals to communicate across that network. Or we could not plug it into any cable at all nowadays, and we use wireless, and now it's using radio frequencies. That's what they do, radio frequencies, woohoo, to communicate ones and zeros as those radio frequencies go up and down across the network. Three different physical mediums, and I haven't even started thinking about other things that could be used to communicate across the network, although that's probably the major ones. We could swap those out irregardless of the layer above it, meaning data link layer. Data link is where we have Ethernet. That's where we define things like MAC addresses, source and destination MAC addresses that's used to communicate across the network. And those MAC addresses are used irregardless of fiber, copper, wireless. It doesn't matter. We're using MAC addresses across all of them, and we could even swap that out. Ethernet is one type of technology. We could use frame relay, which uses DELC addressing. We could use ATM, which uses VPI, VCI pairs. We could use MPLS, which is the current WAN darling of the industry, and that uses tags. I mean, there's different kinds of addressing and communication that we can have at layer 2, and that's why I believe OSI models still exist to this day. You can't group those things into one big old layer. So let's take that practically back to our example that we've been using. This is a cash register at a convenience store that's handling a $5 purchase of a fidget spinner and storing that information about that purchase over here on the store's central server, right? So it can be logged in a database. We talked about how the application processes all that data, makes it into a language that can be understood by both sides, starts and ends the session with the server over there, chooses the protocol of reliability, UDP or TCP, and what port number it's going to use on that protocol to make sure that it communicates with the specific server application that it's looking for, and to make sure that server application communicates back to the specific client application that's running over here. We've talked about how it then uses the logical addressing to identify where that originally came from and where it's finally going. And now it moves down to the data link layer, where it uses what's known as the physical addressing. And this is where many beginning network engineers get just a bit confused. We've got our $5 that was spent for the fidget spinner. That is our data that's being logged in the database. We've added the port numbers to the front. We've added the source and destination IP address to the front. And now right here, we add the source and destination MAC address because we're using Ethernet technology. And the network engineer goes, what? Why do we need an IP address right here and a MAC address right here? Well, this is where I need you to look at the network diagram. Look at what we have here. We've got our switches, we've got our routers, we've got our servers, we've got our clients, and we've got our networks. In another skill, I described the functions of all these different devices on the network. And the function of the router was to separate, to make sure that our network really is our network. And data and communication from our network doesn't accidentally bleed into the outside world. It stops the broadcast communication. It segments the network. And it's accurate to say that every single interface of our router is a network. I don't say it often. I'm going to say it again. Every interface of a router is a network. It literally defines the network. So we have one layer of addressing that's used when we're communicating within that network, and one layer of addressing that's used when we're communicating outside of that network. If you did watch that skill on the functions of these different devices, does anyone remember what kind of address a switch learns? It's a MAC address. It's the Ethernet address. And it stores that in its CAM table, right? So it learns the layer 2, that's what this is, layer 1, 2, 3, 4, et cetera, et cetera, et cetera. It learns the layer 2 address of every device and figures out how to get it where it's going. Now, I still haven't answered the question. And some of you are like, Jeremy, you're not answering the question. Why do we have to have 2? Well, here's the whole reason. We want to be able to communicate with this server over here. That is our end-to-end destination. This computer originated and wants to send it. It could be 1,000 miles away. There could be 50 billion routers that we're going through on the way, but it's still trying to communicate with this one right here. Down at layer 2, it's going to say, what device on my local network can help me get there? Think about it this way. This router has an IP address, right? It's probably, I think I called this one 10.1.1.50 is the address I came up with when we were talking about network layer addressing a few videos ago. This one is probably, if you follow what most people do, 10.1.1.1. It's either the first or the last IP address in that network, right? So here's our problem. I want to get to 10.50.1.20, which is this server's IP address, but I need to use this router to get there. There's only one thing we can put in as the destination IP address. What's it going to be? Is it going to be 10.50.1.20, where we're finally going? Or is it going to be 10.1.1.1, the router that's going to get us to where we're finally going? The answer is this guy. We need to tell it where it's going. The router is just one of many devices that will help us get there, but we still need to identify that device as the helper. That's where this address comes in. Oh, so the destination MAC address of this communication for the $5 fidget transfer would be the router. And the router would get it. It'd be kind of like a buzzkill for the router. And that's the life of a router, a life of buzzkills. He's like, ooh, something for me, because it's got my destination MAC address in there. It rips open the envelope and it's like, oh, this isn't for me at all. This is for some server somewhere. So I'm going to look at my routing table, which is what routers do, and figure out how I can best route this packet to get it to that end destination. That's the function of the data link layer, that physical layer addressing. And once we've got that whole thing, and by the way, this is where we start calling the communication frames, technically, instead of packets. And I'll tell you why that is when we assemble all of this in the next video. For now, once it's got a frame of communication, the device moves it down here to the physical layer, converts all that data to ones and zeros. And I can't tell you how essential it is that you get that. Everything in technology is ones and zeros. As advanced as it is, as amazing as it is to look at me right now at this picture on the screen, and you're like, that's Jeremy. No, I'm an imposter. This is the image that you're seeing is just a bunch of ones and zeros transmitted really fast. That little pixel right there, that's my forehead. A lot of pixels there that are my forehead assembled together into their different colors, which are all just ones and zeros that the computer's interpreting as different shades of tan, right? So that's what's being transmitted across the network. And how we do that is, again, back to the fiber, copper, wireless, just different mechanisms, advanced mechanisms, but just different that we use to send those ones and zeros across the network. That's the job of the data link and physical layer. Oh, now take one more minute. Hit the next video where we're going to put all of this together. For now, I hope this has been informative for you, and I'd like to thank you for viewing.